These are the lesson 4.1 notes on graphing linear equations. The key idea about graphing linear equations is that a linear equation is an equation whose graph is a line. The points on the line are solutions of the equation, right? All of this is important. Linear equation, you can see the word line in there. It has a graph that is a line. And the points, all of the points that make up the line are solutions. Do you recognize that a line is just a whole bunch of points? It's like an infinite number of points stuck together make that line. And all of the points on that line are solutions for that equation. They make the equation true. All right, so we're going to put all of the pieces together. So we're going to have a graph that shows the solutions of a linear equation. This graph represents the equation y equals x plus 1. So you can show a linear equation as a line graph. And we're also going to connect that to making a table of values. All right, so we've got an x coordinate and a y coordinate, and then we have an ordered pair. So the way we got this y coordinate was to just pick a value for x and then substitute it in. If I substitute in -1 for x, -1 plus +1 equals 0. So the y value is 0. You can pick any number that you want to for x, and then you substitute it into the equation, and that will give you a value for y. You should always make 0 one of the values because this point is really important. That's the y-intercept. It tells where it crosses the y-axis, and it helps to orient you on the coordinate plane. If you don't include 0, you end up over here in quadrant 1 or way over here in quadrant 2, and it's hard to tell where you are. All right, so you should always include 0. If you put 0 in there, 0 plus 1 is 1. You put a 2 in there, 2 plus 1 is 3. And then there's the coordinate, the ordered pairs, and use them to plot points, and then you draw a line. Okay, that's the big stuff right there. Okay, so to graph a linear equation, y equals -2x plus 1. Let's make a little table of values just like this. We're going to have an x and a y, and then the ordered pair. And let's see, let's choose 2. If we put in 2, again, you could choose any numbers that you wanted to, but if I put in 2 here, then I've got -2 times 2 is -4. -4 plus 1 is -3. And then I'll have 2, -3. And then remember we said we always want 0. So if I put 0 in there, you'll notice that whatever you choose, whenever you make 0, this part will all cancel it out. -2 times 0 is 0, so that goes away. So that ends up being the y-intercept. Whoops, yeah, I did it right. 0, 1. Okay. And then we need one more point. It only takes 2 points to draw a line, but it's really important to do a third point kind of as a check. If it falls in line with the other 2, then you can be, it kind of gives you a check that you were right. Where if it's out in space somewhere, you've made a mistake. I'm going to choose, let's do 4. All right. If I substitute in 4, I've got -2 times 4 is -8, plus 1 is -7, and I've got 0, 1. All right, so here's the other little guess and checky thing. Once you have these numbers, then you kind of have to look at the numbers to see what quadrant your line is going in. So depending on what numbers you've chosen here, these ordered pairs will be a little different. So I can look at these and I can see that I've got some positive x's and there's a negative y. And so I think that I need to draw my axis in the second quadrant. All right, so I'm going to draw, let's see, how about like this? When you are doing your own work, you might want to use pencil so that if you make a mistake and put it in the wrong place, you can erase. And if you make it, it's okay. So let's put, this is the x-axis. This is the y-axis. And then we want to plot these points. So I'm going to go, here's the origin. So I'm going to start over 2, 1, 2, and down 1, 2, 3. Went to 0, positive 1, so over 0 and up 1. That's my y-intercept. And then, whoops, I wrote the wrong thing there, didn't I? Did you write the wrong thing on your paper? Did you see that I made a mistake? All right. So then I need positive 4, 1, 2, 3, 4, and down 7. 1, 2, 3, 4, 5, 6, 7. All right. And then with your ruler, if you've solved everything correctly, they should fall into a line. All right. A couple things to just point out here that we'll hit in later sections. This point is important. That's the y-intercept. It's the place where it crosses the y-axis. It's this point where the x is 0. And then also noticing here, that because this is negative, this line is coming down, all right? And step 3 was draw a line through the points. Okay. You have 2 U-tries and a whole page to work on. Yeah, whatever. Okay. All right, then we have horizontal and vertical lines. They are kind of the opposite of what they sound like they would be. Right? Horizontal, that's like the horizon. So it looks like this. It's a straight line. The graph of y equals some number is a horizontal line passing through 0b. All right. The way you can think about that, it seems kind of the opposite, like it's a horizontal line, but it's y equals a number, and y is the vertical axis, and so that's a little confusing. But if you think about it, to give you an example with a number, let's think about a number. Like what if you said y equals 4, all right? So if all of the y values are 4, so that's like go over 0 and up 4, go over 1 up 4, go over 2 up 4, go over 3 up 4, go negative 3 up 4, go negative 5 up 4, go negative a million up 4. No matter what the x value is, the y value is going to be 4, and so it's going to make a horizontal line. I have to think about that every time. I always have that mental image of y equals a number. Okay, that means that all the y values were that number. Okay, so that's horizontal, right? And the graph of the graph of x equals a is a vertical line passing through a0. So if you just have x equals a number, that's saying, well, all of the x's are the same. So I'm always going to go over the same amount, and then I can go up or down, right? So it makes a vertical line. You can memorize that, or you can figure it out every time. All right, so let's do a little drawing. Graph y equals -3. Let's see. Let's draw a little crissy-cross. Sorry, a coordinate plane. All right, and then I'm going to go, let's see, if I go over go over 1, then I need to go 1, 2, 1, 2, 3. And what about if my x was 0? Then y would still be -3. What about if my x is 1, 2, 3, 4, 5? Oh, wait a minute, y is still -3. What if x is negative? What if x is 1, 2, 3? Oh, it's still -3. Y is always -3. So it's a horizontal line through there. Okay, that's y is equal to -3, no matter what the x is. Right? Same thing. So now we know this must be a vertical line where x is equal to 2. So if all the x's are equal to 2, that's this way, right? X is 2, y could be anything. Whoops, sorry about that. Right? There's x is equal to 2. Okay. And then again, you have 2 u-tris. You're graphing x equal to -4 and y equal to -1.5. Okay, and then we have a real-life example. Right, so the wind speed, y, in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. All right, there's a lot of stuff in here, and this is important stuff too. So when they give you a word problem, they will always tell you what the variables stand for. So in this one, the wind speed is y, and it's in miles per hour. So we can go ahead and label that. Here is y, and it is in, this is speed, right? It's in miles per hour. Okay. And then the x is the number of hours. Right? And then here's the equation that you're going to use. So we're going to start by making a table of values. Let's see. Yes, I want to do it like that. Okay, x and y. And then the ordered pair that I will graph. Okay. Let's always start with 0. If I substitute 0 in, then I have 2 times 0 is 0, plus 66 is 66. Does it make sense to have any negative values in this chart? Can I have a negative number of hours? Not really. Okay, so just need to stick to positive numbers. And you can put in any that I want. I'll go ahead and put in 1. If I put in 1, then I've got 2 times 1 is 2, plus 66 is 68. And if I put in 2, I can see that's going up by 2, right? Oh my goodness, I made a mistake again. All right. And then we have to choose a scale for our graph. So we're going to, my graph here at 0 is going to start right at 66. And then after it starts at 66, then it goes up by 2s, right? So I think it makes sense to have a little break in the graph there. So it has to start at, is that where I want it? Okay. Yep. So there's 0. And then after the break, we can start with 60. And then you can count by 2s. It wouldn't make sense to count by 2s through the whole thing. That would be ridiculous. But if you count by 10s, then it's really hard to graph these little tiny numbers. So you can put a break in the graph. And I'm not sure you got to do that much last year. We kind of lost some stuff. You can number every one. So you can do 62, 64, 66. Sometimes I skip numbering one just because it's too crowded, but I'm still going to leave space for it. So here's 60, 62, 64, 66, 68. Did I do that right? 62, 4, 6, 8, 70. Okay, there's 72. All right. And then our hours are counting by ones. 1, 2, 3, 4. Okay. 5, 6, 7, 8. So after 0 hours, the wind speed is 66 miles per hour, which is right there. And after 1 hour, it is at 68. And after 2 hours, it's at 70. Then use your ruler. Are we okay so far? What do we want to pull out of this? The y-intercept right here. The y-intercept is 66. And a tiny review from last year where we talked about slope, and that is how much it's going up. Every time we go over 1, we're going up 2. It's because we counted by 2s, this vertical counts as 2. You can see it's going up 2, up 2, up 2. So the slope is equal to 2. All right. So then they ask us, when does the storm become a hurricane? So kind of the whole purpose of collecting data and finding a pattern so that you can make a graph is so that you can make a prediction, right? We want to be able to predict if this hurricane keeps picking up speed, or if the storm keeps picking up speed, when will it turn into a hurricane, right? It says that a tropical storm becomes a hurricane when the wind speeds are at least 74 miles per hour. So I need to find 74 on my graph. Here's 68, 70, 72, 74. And I need to draw a little line out there. Okay, there's 72. And I come down to 4 hours, right? So at 4 hours, the speed equals 74. All right. Told me I wanted 74. That's speed. Here's speed on my y-axis. Go up to 74. Go over to where it meets the line, and then find the x value that goes with that. Right? You have one u-try. They give you a different equation. So you need to make your little table of values, and then you can find out when that storm becomes a hurricane. So this one is picking up speed less quickly, and it looks like it's starting. We didn't talk about this value, what the y-intercept means. If we were in class, I would have you answer that question. Looks to me like the y-intercept is kind of the starting speed, right? When it first starts out, it's at 66 miles an hour, and then as time goes by, it picks up more and more speed. Okay. And here are the answers to the u-tries. So you can pause here and check to make sure that you graphed everything correctly.